last couple things I want to talk about here. Almost done. We have 4 more slides. We actually do have 2 jet streams. We have a polar jet stream and a subtropical jet stream. What is a jet stream? There you go. Yeah, it's basically like the ocean currents, but rather instead of ocean, we have air. All right, so this is a very strong air current. It's very narrow, but it goes extremely fast. And so,
what gives us that narrow?
Basically, if you go back to this map, your jet stream is right in here. So it's this convergence of winds coming together that creates your jet stream. So we have a jet stream there, and then we have another jet stream. No, not there. Right here.
Is it because, like, as the two come together, they like force each other, and then it's
Yes.
That?
Now.
It's a very strong air current.
Yes. It's very, very fast. Very strong, and it undulates. Okay, again, sorry for my non-readers out there. Undulates. It means it goes up and down. Okay? It's very sinuous. It's almost sinusoidal. By the way, this is called synonyms. By the way, that means words that are the same meaning. So basically, our jet streams undulate. And what happens when they undulate, they actually create different air pressures, which is really kind of cool and very simple to understand. When we call this a peak, so it goes up to the north, call that a peak, that's a high pressure sitting inside the peak. When it creates a trough, that's a low pressure. Okay.
I see that on the weather channel.
Yes. So you're looking at a map, and you can see the highs and lows on the map. You can actually trace out the path of the jet stream. Jet streams are really important when we start talking about winter. It's kind of fun to watch that jet stream drop very rapidly. And it's when we go from hanging out at 30 degrees, also when we get down to 15. That's usually an indication that the jet stream is directly over us. Because the jet stream that we have interaction with is this polar jet stream.
Woo!
So it brings with it a lot of cold air, very, very cold air. Alright? So we got highs and lows. Which brings me to the next point. We look at air pressure, we have highs and lows. Everything's trying to reach equilibrium. So that means that your air pressure moves from high pressures to low pressures. This map shows real-time wind measurements around the country.
Not really windy over here.
Not really. What do you notice over here, though?
It's very
Yeah, it's very windy. By the way, notice that all this air is coming out of here. What does that tell you that's sitting right here? What type of pressure system? High pressure. High pressure spits out the air. Low pressures suck it in. Okay? So we have all this wind's coming out of here, so which means we have a high pressure sitting up here. What's sitting over here?
hello.
How do you know?
Because that wind is hello.
Yeah, all that wind's coming together right here. Again, what's sitting up here? Take a look, watch your wind. All this wind
Hello.
is sitting right here, so you got low pressure sitting up here.
So low pressure pulls wind is high. Which is low.
Yep. Now, what's setting right here in this region? You got right where my cursor is. What's sitting there?
Like geographically?
Yeah, what type of air pressure? No, not low. the high pressure.
Oh, because it's pushing, there's something, there's not a lot of wind right there.
It's pushing it out. Okay. Now, one more thing I want to point out. Notice the rotation. This is rotation. Okay, that's what we call an anticyclone. We need to write that down. We have cyclones, which are low pressures, and we have anticyclones, which are high pressure. Cyclones rotate clockwise. I'll make that counterclockwise. Anticyclones rotate clockwise. No momento. So when we look at this image, you can see this very clear rotation of the air in this region, and it's rotating clockwise, so we would say that is high pressure. When we look at this one, though, we're rotating and a counter. In fact, again, what's sitting right here, right above El Paso? What's sitting right here? Again, yeah, you see all the air being dispersed out of there? Let's go to the weather map. What do you notice? This entire region is nothing but what? High pressure. Oh, remember what we said was sitting above Michigan? Low pressure. What was sitting way over here? Low pressure. Oh, and hey, do you remember this part right here? What was sitting right above Minnesota? So that's one of the things I want to show you guys there. I think you might like to know that.
That was H and L. Yeah.
H means high pressures, L's mean low pressures. Okay. By the way, do you guys see these things called fronts? That's tomorrow's lesson. Now, what's kind of interesting about this? Do you notice that the highs never have a front attached to them? That's because it's always pushing the air away, and the lows are sucking the air in. So all of your fronts are always connected to the L's. And your fronts will never be connected to the high pressures. Okay. All right, that's all I've got for you. Yes?
I remember going to Michigan last summer, and we were on the highway, and it was the front. Everything was wide open sky. It was a really long stretch of time, like a wall. And it spread and it went across. I could see it was really stop. It was a pretty big pressure.
That's pretty cool.
I've got pictures of it somewhere.